Hello everyone. So today I'm going to show you how to make this character's tail adjust to the ground underneath. So as you can see here, the character's tail is automatically adjusted to match the slope of the ground, and it tries to adjust as it moves as well. So this is what I'm going to work on today. This is going to be quite a long episode, and with some trial and error stuff. So let's see how to achieve this procedural system, animation system for the crocodile character. And here I'm only going to focus on this adjusting the tail part to the ground, nothing else. And also I'm going to make the project files available for you to download, but the crocodile mesh will not be there because as this is from a marketplace asset, I don't have the rights to share it. Alright, let's see how to do this. And this episode is sponsored by this generous patron. Thank you very much for the support you are giving me. Okay, so this is the crocodile character I have, and at the moment it doesn't have any eye case. So let's see how to make it align, how to make its body align to the ground. So this is the animation blueprint I have used. It's just set the character animation and the speed, and the anim graph. Anim graph is like this. It doesn't have anything. It's just a 2D blend space with moment animations. Right, and that part is not very important. Here is where we set the speed. So we are not going to focus on these things. These are pretty basic. We're going to focus on the IK part, where the character's body align to the ground underneath. So it's like this at the moment. As you can see, the tail is buried on the ground when we move down like this, and when we move up, head is buried on the ground. Right, to prevent this, let's take a look at the skeleton of the character. It's like this, and the tail, we can bend it like this. Cool. We have tail bones like this. Great. And the head, we have neck like this. Okay. Spine. Great. Alright, so where should we get started? Root is here. This is the whole body. Pelvis is also affecting the whole body. The spine only affects, right, spine only affects the front part of the character, and tail affect this part. Cool. So how do we get started? Let's see. Here let's add let me disconnect it back. So if you type IK here, no, if you type IK outside, we have this spline IK. spline 𝐂𝐴 constrain a chain of bone to a spline. So if you select these, if you check these tail bones, I think we can approximate that into a spline. Let me show all hierarchies. See, I think we can use that one for this. So let me connect it like this and connect it. Spline 𝐂𝐴. Right, now as the start bone I'll set crocodile tail, and the end bone crocodile tail 6, and compile. See, oh, we can control the tail like this now. Great. So here if I add a location offset 20, oh, yeah, I think we can use it. Let's see how it looks here. Yeah, only the latter part is lifted a little bit. Okay, let's start with this then. So first, for testing, I'll make this alpha 0, and as if the crocodile is on the ground, let's test this with the flat surface. Just to see how it should look if the character is on a flat surface. Okay, it is like this. Alright, now I'll make it 1. Right, when I have the character like this is the way it looks. Okay, now let's start from the very end bone, the bone in the very end. So for this, how can we set the control points? We have to figure that out now. Right. We can actually expose them here, the control points. We have to expose all of them. Okay, no problem. So control point 6. So for this, let's define a custom data structure, because we need to, for each bone we need to have couple of details, like the offset we need to apply, and also to keep a realistic behavior we need to have the maximum offset that we can have per bone. So we would gonna need multiple data. So therefore, where do we have this? Here. Let's create a new folder. pp blueprints. structure. I'll call it on data. We need actually at the moment I only need to vertically adjust the bone, so y offset, another variable max y offset. Instead of capital I'll use underscore, that's clear. Max y offset, is that all we need? I guess so. Right, now here I'll add a variable in the type of on data. I'm gonna change the type to on data, and I'm gonna convert this to a array. Oh, we need a variable to hold the bone name as well. So I'll add a new variable, bone name. It should be a name. Right, now I'm gonna add, so here we have actually, let's see, 0 to 6, 7 elements. So let's add 7 elements here also. And we have to define values here. For max y offset, as the default value, I'll give 20. And we might need a min y offset as well. This should be also a float. Let's put the bone name first. Right, now the first one, the bone name is tail. Oh, it crashed. Why? Right, I restarted the editor. As the min y offset default value, I'll give -20 and save. Hope it wouldn't crash again. Right, now the first bone name is this, crocodile tail. Second bone name, oh wait, yeah, that's correct. Second bone name is tail 1, like that until tail 6. Tail 2, tail 3, four, 5, 6. Okay, now let's split this. No, let's define a PO function. Get bone control. Is that a good name? Let's just use it. Okay, and as the output I'm gonna give a control point. Wait, what's the type? It's a transform. Okay, so I'm gonna call it get bone transform. Transform, and as the input I'm going to define bone index. Right, we don't need this. Now here, bone index should be an integer. This is 1. We need 6. Two, 3, 4, 0, 1, 2, 3, 4, 5. Sorry, we need 7, 6. Connect them like this. Then we can start working on finding out the actual bone transformations required. Right, let's see how it looks. It looks fine. Right, now let's start implementing this get bone transform function. So using this index and using this bone data, we can get the required bone data for this specified index. By splitting this, we can access bone name, y offset, max y offset, and min y offset. And also we can split this transform like this as well. But wait, we have a problem here. Let me set the default forward value to 1 so we can inspect it. Yeah, alright, this is the problem. As you can see here, this bones, if I set this to 0, there is a movement here in the horizontal plane. That is also overridden if I use it. Set this to 1. Yeah, and at the moment I'm not returning anything. Those were just for testing. So I don't think we can use spline 𝐂𝐴 for this. So what actually we can use here? Let me put this aside. I think then we should use two generic the usual 2 bone 𝐂𝐴 for each of these bones. Alright, so let's start with 1 2 bone 𝐂𝐴. What should we start? Let's start with the tail, the last bone. Let me change the speed forward to none, 0, so easier to work. This is effector location. And can I preserve the movement in horizontal plane with this? Let's see. No, I can't do that here also. So how can I make this only affect the vertical part of the location? So that means we can't use that as well. So what's the only thing that we can use then? Yeah, I think transform modify bone. Yeah, we can use this. Using this we can preserve this motion while modifying it. So here, for example, if this character is moving downhill or something, we can bend upward the tail. Let's test it with tail 1. Rotation I'll set to existing in the parent bone space. X, what if I set to 10? Did it show any difference? 45. Oh, Okay, alright, this is what we need to change. Okay, so how do we do this? I'm gonna modify this function. Instead of returning the transform, I'm gonna return rotation. Not vector, rotate. Get bone rotation. Alright, get bone rotation, connect rotation like this, and as the bone index, so here tail 1, that means index is 1. Yeah, potentially thread unsafe call. Okay, then let's get bone data. Oh, not really. This is not thread unsafe. Actually, if I just do it like this, let's see how it turns out, and we can figure out this thread problem later. So now, as we inspected before, we only need to change this 𝐂𝐻 component. So I think this is true for all the bones. Let's try another bone as well. Yeah, only the 𝐶 part. Okay, so in the bone data, instead of y offset, I'll call it your offset. Right, now here I'll split this and return the your offset like this. What if we replace this with the macro? Can we get rid of the thread unsafe part then? Oh, we can't have macros here. Alright, then I'm gonna stick with this regardless of the warning. Alright, then in the event graph, right, now in the event graph I'm gonna define another function like this. Check, no, update won't transform. Update bond data, not transform. As the input, I'm gonna give an integer bond index. Right, so this is what I'm gonna do for this bone. Let's say crocodile tail. I'm gonna check the location of the next bone, the bone next to that, and if it is buried on the ground, or if it is too high above the ground other than the intended offset from the ground, I'm gonna add some rotation offset to this bone. So like this. First we have the character get socket location from the mesh, bone data. Oh, we can use, yeah, we can use bone data get the bone index. Using this we can get the bone name of this of the bone defined by this index and the next bone. So we should not give sixth bone of this bone data here, because we would get a null or index out of bounds error. Keep that in mind. Right, now like this we can get the names of the first bone and the second bone, and we can get the locations of those bones like this. Right, now I'm gonna add another variable here for each bone, desired ground of set should be a float. And what is the desired ground offset for a bone? I'm not sure, let's say 5 for now. Then let's do align trace by channel. Let's use the camera channel, and as the starting position I'm gonna use the location of the check bone, and as the end I'm gonna add minus 50 to this. Like this. And yeah, as the start position, let's do something above the ground, like 50 above this bone. That should be better. And if we get a hit, break the hit result and get the location. Subtract the hit result location from the socket location. And here we only concerned about the Z component. If this Z component is larger than this desired ground offset, what we should do is we should rotate upward, rotate downward the current bone that we are considering. So that means moving down means get the yaw offset, when I set 45 it moved down, right? When I set minus value it moves up. Okay, so if I want to move down, what I should do is add value to this bone. So I'll add 0.1 here, and we need to set it with as the new value. We can select what we add, whether we add or subtract based on the result of this. If it is positive, that means it should be plus, otherwise it needs to be negative. And set get the bone index and break. Let's use this one instead. So we can set member the Y offset with this updated value. Okay, now let's call this update bone data function for bone index 1 and bone index 2 and bone index 3 and 4. That should be enough for testing. I'll set the debug type for one frame as well. No, let's only try the first bone for at first, because I have set only for the tail one, this transform modify bone. Alright, now let's see what happens. Yeah, it moves down until Well, I don't have a clear idea what's this desired ground offset should be, but we can find out that if we print this value on a flat ground, we should get the desired value 20, right? So for the bone one, desired ground offset should be 20. And still it moves down. Sorry, I should set it for the next bone. Yeah, okay, so that one seems fine. Okay, I think it adjusts properly. Now the next bones. Second bone, and we need to add a transform modify bone node as well for that. So to work with the second bone, for the third bone I'll add 10 as the desired ground offset. Yeah, now that is also on the ground, sits on the ground properly. Let's see what happens when you move down. Yeah, it is working. But it's still not perfect. I'll increase this to 25 and this to 15 and this one 10, this one 7. I'm just putting numbers, I'm not sure. This one 5. Okay, three, 4. Let's connect 3 and 4 as well. Okay, when we move up, it is not working properly because we haven't worked on the front part of the crocodile yet. It is adjusting. Right, so we can speed up this adjust speed if I change this instead of 0.1, let's say 0.2. This should speed up the adjusting. And I think we should apply this for bond 0 as well in this bond data. For the bond one, what's the desired? 20. I'll make it 30. Oh, that's bad. What is that? So if we don't get the hit, I think we should do the same thing. And we should make it closer to 0. So get the y offset lerp to 0 using alpha as 0.2. Why the latter part is not touching the ground here? Oh, that's a problem. Can we increase this? And also here let's clamp these values, this y offset, using this max your offset and min your offset. What are the default values for that? 20. Right, that should be fine, so that we can avoid extreme cases where the tail get buried on the ground in an unnatural way. So to address issues like this, right, we have to adjust the full body of the crocodile as well. Let's do that now. Let's define a new function, get calculate body rotation. Now here from the character mesh, we can get bone location, socket location. I need the location of this socket. What is that? Pelvis. And do a line trace. Oh well, actually we can upgrade this one, promote this one to a function. I'll call it trace bone. Hit if it is true or false, out hit, and the bone location. And here we can use that function. No need to rewrite the code. As the socket name, use pelvis. And we also need to trace this bone as well. Neck. Oh no, let's use this one. Yeah, it's neck. right? So if we get hits for both outputs, we can do this calculation without any issue. The character is on the ground. Both hits are true means character is on the ground. Pelvis to neck. Let's break this. Hit result. I think we only need the location. Break these two. And from the pelvis to neck hit location, let's find look at rotation from pelvis to the neck. Start should be pelvis and should be neck. And let's print this. I'm going to remove this print. We don't need that anymore. And let's call up calculate body rotation also here. Okay, it's P2Y22 and R0. And I think we need to increase the trace bone, this offsets 150. Let's try. Now pitch is increasing as I move down, and as I move up also pitch is increasing. $42 now. It's minus now. Okay, so that's what we need to consider. So using that data, we can adjust the rotation of the character's body. Let's do it here. Using a transform modify bone, and let's apply that to where? The pelvis of the character. Rotation, add to existing, and here let's promote this to a variable body rotation offset. Let's directly put this here and see what happens. Oh, it's going crazy. Now this should be parent bone space. It is somewhat working. I think we should disregard the yaw part. So let's try only pitch. Yeah, pitch is working fine. And here for that part I think we should apply a roll. Oh, actually roll doesn't show any difference here because when we calculate the look at rotation from the back of the crocodile to the front of the crocodile, if we don't really get a value for that, so it won't work here. And I think that is too steep. Right. Oh, sorry, we have done a major mistake here. I haven't changed. This is tail 1. This should be tail 2. This should be tail 3. This is not tail 1, just tail. This is tail 1. This should be tail 2. This should be tail 3. This should be tail 4. Right, now let's see how it looks. Tail looks kind of vibrating. And as we move down, yeah, tail is working pretty good. And to get this, the reason for this vibrating effect is this. When we update this, we have increased this to get faster results. 0.2. We should then decrease that speed. So we should be able to get rid of that vibrating effect. Okay, now the character keeps the tail on the ground most of the time. Right, so I'm gonna stop this episode right here. To prevent that vibration effect, we can do something like this. Oh, we already know this. Let's calculate. No, let's do nearly equal. With this difference and the required ground clearance, like a 0.2 difference. If that is the case, let's have a branch here. If this is true, let's not change anything. So only if it is false, I'll update the value. So we should be able to get rid of the vibration. See, now it's not there. Okay, so here is the final demonstration. I added the trace bone and update bone value functions to the fifth bone as well, so it places the tail on the ground properly. Alright, so with that I'm gonna stop this episode right here. Maybe in a future episode we can work on stuff like, so for example, if I get down, see the character snaps. We can work on such problems as well. Alright, so I'm going to stop this episode right here. It has taken too long. And thanks for watching. So I will make the project files available for the download, but please note that this Crocodile is from a marketplace asset, so therefore I will not include that, but I will make this code I have created here, the blueprints, available for you to download. And thanks for watching. See you in another episode. Goodbye.